Hello guys, welcome to Ferdinand Tutorials. In this video, we're going to be looking at disaccharides. Now, the disaccharides we'll be looking at are maltose, sucrose, and lactose. I'm not just going to be explaining them, I will be showing you their structures and their formation and the carbon atom that we usually use to form them. So what's the end to find out how we form these different disaccharides of maltose, sucrose, and lactose. Do not click off. Now, when you hear about disaccharides, what we are looking at is a particular sugar that is formed from the combination of two monosaccharides units. Now, there are three important disaccharides I want us to look at here. We'll begin to look at what we call the lactose, we'll begin to look at the sucrose, and then we'll begin to look at the maltose. Now, each of these disaccharides are formed from the combination of monosaccharide units. Now, there are monosaccharide units that are very essential in the formation of these disaccharides. We'll begin to look at the glucose, the galactose, and the fructose. Now, I told you that there are three important disaccharides I want us to look at, which I mentioned maltose, and then I mentioned sucrose, and then I looked at what we call lactose. Now, for this particular disaccharides to be formed, I told you that two monosaccharide units are formed together. For this maltose, for maltose to be formed, there must be glucose unit plus what? Glucose unit. That's glucose plus glucose combined together to form maltose. Now, for sucrose to be formed, we're looking at glucose plus fructose. Now, for lactose to be formed, we're looking at glucose and what? Galactose. That is why I drew these three important monosaccharides on the board. That means we cannot form any disaccharide, especially these three important disaccharides, without this what? This monosaccharide unit. So we begin to look at the D-glucose. Look at the structure of D-glucose. Look at the galactose. This is the structure of D-galactose. Now this is fructose. This is the structure of what? D-fructose. If you look at this, these are aldose sugars. Both glucose and galactose are what? Aldose sugars. But this particular man is what? A ketone sugar because of the what? Ketone functional group here. Are we together now? Now if we begin to look at this sugar now, these are 6 carbon sugar. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Both glucose and galactose are 6 carbon sugar. So we call them what? Aldohexose because they are of aldehyde functional group. Now if we come here, this is a ketone functional group, CO, and it has 6 carbon atoms. So it's called what? A ketohexose. So we cannot form any disaccharide, especially these three disaccharide, maltose, sucrose, and what? Lactose, without the combination of this what? Separate monosaccharide. Okay, let's look at the first disaccharide, which is maltose. Now, in maltose, we are saying that two glucose units combine together to form this disaccharide called what? Maltose. That means this is a glucose unit, right? Also, this is another what? Another glucose unit. Now, this structure of glucose is called the Hayward structure of glucose. Hayward. Are we there now? Structure of what? Of glucose. Now, remember that this is a glucose unit plus another glucose unit. Glucose is a 6 carbon sugar. This is carbon 1. This is carbon 2. This is 1. Remember this line here, this is carbon. So this is carbon 2. This is also another carbon. This is carbon 3. This is another carbon, carbon 4. This is another carbon. This is carbon 5. And this is carbon 6. The same thing here, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and this is what? Carbon 6. Now, when these two monosaccharides combine together, they carry out what we call condensation reaction. They undergo what we call what? Condensation reaction. Now, what is condensation reaction? In condensation reaction, we are saying two simple molecules join together to form a giant molecule with the liberation of what? Of water molecule. Now, let's combine these two monosaccharides together. Now, when these glucose and glucose combine together, the carbon 4 and the carbon 1 join together. This is carbon 4. Can we see? This is carbon 1. Now, they join together through a particular bond called glycosidic bond. This is what I mean by glycosidic bond. Glycosidic bond. Now, so for them to join together, look at what will happen. OH, remember I told you condensation reaction with the liberation of what? H2O, which is what? Water. So now, these two OH, remember OH will leave. So these two monosaccharides will join together. Are we there now? With the liberation of what? H2O. So this is a disaccharide. This is a structure of maltose. This is how maltose is formed. I told you that monosaccharide, this is glucose, glucose joined together through a bond called what? Glycosidic bond. This is where the bond is formed in carbon 1 and carbon 4. So we call this bond alpha 1,4 glycosidic, alpha 1,4 glycosidic bond. Now, why is it alpha? Now, whenever the H is up and the OH is down, that particular bond, that particular carbon atom is what? in an alpha carbon atom. So that means if OH is down, this particular carbon atom is an alpha carbon atom because the OH is pointing downwards. When the OH is pointing upward, it is called a beta carbon atom. So this is a beta carbon atom. This is an alpha. If we come here, OH is pointing downward. So this is alpha carbon atom. Here, OH is pointing downward. This is what? Alpha carbon atom. So alpha 1 and alpha 4. That's why we say what? Alpha 1,4 glycosidic bond. That's the bond that held these two monosaccharides together to form what? A maltose. Now, when we're talking about disaccharide, we say that disaccharide is a particular sugar that is formed when we have two combination of what? Monosaccharides. In this case, we want to look at lactose. And then we say that for lactose to be formed, there are two different monosaccharides that come together. We begin to look at what? Galactose and glucose. Now, for a particular lactose, which is a disaccharide to be formed, we don't usually use alpha sugar. We use beta sugar. I will explain. Now, if you come here, this is an alpha sugar. This is alpha galactose. This is alpha glucose. Now, this is this sugar. If you've not watched my video on Enlightenment, you can go watch it. The D and L sugars. Now, if we come here, this is carbon 1, this is carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Now, remember last night I taught you that when the H is up and the OH is down, that particular carbon is an alpha carbon. But when the OH is up and then the H is down, that particular carbon is what? A beta carbon. Now, for here, what makes a sugar an alpha sugar is when the H is up and then the OH is down in the first carbon atom. That is, in this first carbon atom, whenever your H is up and then the OH is down, that particular sugar is what? An alpha sugar. Right? Now, but when the OH is up and then the H is down, that particular sugar is what? A beta sugar. So this particular sugar is what? An alpha galactose. Why is it an alpha galactose? Because in the carbon 1, the H is up and the OH is down. That's alpha. Here, this is galactose. This is glucose. Why is it an alpha? Because the H is up, the OH is down. Now, in the formation of lactose, we don't usually use an alpha sugar. We use a beta sugar. That means only in the carbon 1 now, our OH will be up and then the H will be down. That's how we're going to write this. So here now, in carbon 1, this is my carbon 1. What will happen here? Instead of H to be here, OH will be up, H will be down. So we have OH, H. Every other thing will remain the same. The only change that will happen will only be in the carbon 1. So here I will still have H, OH. Remember, this is galactose. Here I will still have HO. That's the same thing as OH. H, HO, H. Here CH2OH. And then this is my H. So this is a beta D-galactose. Why is it a beta? Because of the what? Carbon 1. In the carbon 1, OH is up, H is down. Are you getting what I'm saying? So when you see a particular sugar in this Hayward structure, then the OH is up, the H is down. Know that particular sugar is what? A beta sugar. So if I come to my glucose here, my beta glucose, remember there will be a change in the carbon 1 only. So here will now be OH will go up, H will come down. So here will be OH, H. Every other thing will remain the same. H, OH. In the carbon 3, I will have HO, H. And then I'll have here H, OH, and then CH2, OH, and then I have H. Now, this is a beta D-galactose, and this is what? A beta D-glucose. The question is, why do we use a beta sugar to form a lactose? Now, the answer to that question is this. Now, when this beta sugar combines together, there is a bond that usually forms. The linkage that is holding these two monosaccharides together is what we call beta 1,4 glycosidic bond. Beta 1,4 glycosidic bond. Now, you cannot find beta 1,4 glycosidic bond on an alpha carbon atom. So, for us to get our beta 1,4, that means the sugar needs to be reconverted to beta sugars. So, if I want to form my disaccharide here, just as I taught you, yesterday, I told you that in condensation reaction, simple molecules come together to form what? To form a giant molecule, which is this lactose. So, these are the two, monosaccharides. So, what do they do here? Now, the OH will come here. These two OH will come together. Remember, when they come here, OH will be holding the two of them together. So the OH will leave. OH will leave. Remember, OH plus OH will give us H2O plus O. So the O is what is holding these two, monosaccharides together. And the H2O has been liberated. That's what makes it a condensation reaction. So this beta is called what? Beta. This bond is called beta 1,4 glycosidic bond. Why is it beta 1,4 glycosidic bond? Because this is carbon 1 and this is carbon 1, carbon 2, carbon 3, and carbon 4. So the bond happened in the carbon 1 and the carbon 4. That is carbon 1 of what? D-galactose, and carbon 4 of what? D-glucose. That is how a lactose is being formed. Okay, I want us to look at the third disaccharide, which is sucrose. Now, I've already given you what we call the maltose, the lactose, and we want to look at the sucrose, which is the third structure. Now when we begin to look at sucrose, we begin to say that for sucrose to be formed, we have glucose plus what? Plus fructose. And now when we begin to look at glucose, this is alpha glucose. Already I taught you that when we're talking about alpha glucose, we're talking about the what? The carbon 1 must be what? An alpha carbon atom. And what makes a carbon an alpha carbon atom? When the H is up and the OH is down. But in the carbon 1, if the OH is up and the H is down, that particular sugar is what? A beta sugar. So this is an alpha glucose. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and this is what? Carbon 6. If we come here to fructose, in fructose, this is carbon 1, this is carbon 2, this is carbon 3, carbon 4, carbon 5, and this is what? Carbon 6. Now if we come here, look up, in the carbon 1, OH is pointing down. Are we there now? When OH is pointing down, that sugar is what? An alpha sugar. In this case, now this is alpha fructose. But for us to form a sucrose, already remember we said glucose plus fructose. What we are going to do is alpha glucose plus what? A beta fructose. Why are we using beta fructose? Because in the bond, which is the glycosidic bond, it's usually alpha 1 beta 2 glycosidic bond. Are we there now? So that means we are going to have alpha glucose, and then we must have what? A beta fructose. So for us to have an alpha glucose, let's say this is our glucose here. Remember, alpha glucose in the carbon 1 is usually an alpha carbon atom. So HOH, here is also HOH, which is carbon 2. In carbon 3, HOH. In carbon 4, HOH. And then here we have CH2OH, and then we have H. Right? Remember, this is my carbon 1. This is my carbon 2, carbon 3, carbon 4, carbon 5, and this is what? Carbon 6. Now if we come to fructose here, remember in fructose it will not be beta fructose. Beta fructose simply means that OH will come up. Remember, if OH is up here now, I'm going to have something like this, OH. I'm going to have CH2OH. I'm not going, every other thing will remain the same. So I'm also going to have HOH. I'm going to have HOH, and then I'm going to have CH2OH, and then I'm going to have H. Now if I'm naming, this is my what? I'm starting from here. This is carbon 1. Remember, this is where I started. C it usually starts, so it's carbon 1. Here must also be my what? My carbon 1. This is carbon 2, carbon 3, carbon 4, and here we have carbon 5, and this is what? Carbon 6. Now, generally, if we want to form a bond, the bond usually comes between, the carbon 1 of the alpha glucose and the carbon 2 of the what? Beta fructose. So what we are going to do here, remember, under condensation reaction, when we have two simple molecules joined together, they must form what? A complex molecule with the liberation of another molecule like what? H2O. So in this case, what is going to be liberated? So remember, OH is up here, OH is down here. So I'm going to join these two bonds together, but joining it together with a bond, are we there now? This is O. Remember, this is what? This is a particular disaccharide called what? Sucrose. This is how sucrose is formed, plus H2O. So this is, the bond here is what? Alpha 1 beta 2 glycosidic bond. This is how sucrose is formed. We don't form sucrose with an alpha fructose. We form sucrose with what? A beta fructose. Thank you.